Good day, everyone. My name is Eden Sumo. I'm a Master's of Science student at Grand Canyon University, currently majoring in cybersecurity, and this presentation is for my CYB 610 Penetration Testing and Risk Management course. Today, I will be presenting my findings on vulnerability analysis and control exploitation of my Keyaptric One virtual machine, which was done in an isolated lab environment. Throughout this presentation, I will demonstrate how I use Nmap tool to conduct multiple vulnerability scans and enumeration on my Keyaptric Linux system from my Kali virtual machine. Let's first begin by reviewing the assignment objectives. Using Nmap, which is the industry standard tool for network discovery and security auditing of target systems, I first conducted enumeration and footprinting of my Keyaptric One machine to identify open ports, running services, and server versions. I performed multiple Nmap scans using various techniques to gather detailed information about the target system. I then apply flaw hypothesis methodology to predict potential vulnerability based on my enumeration findings. After that, I created a vulnerability map to visualize the relationship between services and their associated security flaws. Finally, I researched at least two vulnerabilities in depth, documenting their root causes and potential impact. All of these findings are documented with screenshots and demonstration in this video presentation. Now let's move on to the lab environment setup. So in my Oracle VirtualBox lab, I booted up my Kali Linux and verified network connectivity using ifconfig command. Initially, my IP address started with a 10, indicating a NAT network configuration. I had to switch it to a bridge network adapter through the Ethernet settings on the right of the screen. I then ran an ifconfig again and confirmed my new IP started with a 192 as shown in a split terminal on the right. This confirmed both machines were on the same network and ready for scanning. So for my initial reconnaissance, I performed two Nmap scans on my target system, the subnet scan, which is used to identify all live hosts within a network range. I first ran this scan to discover active hosts on the network, and it was able to identify my Capture One machine with the IP address of 192.168.56.102. Since it's the only machine I'm running, you can see in the result it shows all open ports as well. The OS detection scan also used to fingerprint the target system and identify the operating system. So I ran this scan using nmap-o command with the Capture One IP address. This scan was also able to discover several open ports and services running on my target system. As you can see, the results showed port 22 running SSH, port 80 running HTTP, ports 139 and 445 running SMB services, etc. The OS detection also indicated my target is running a Linux 2.4 kernel system and also showed the network distance as one hop since I'm on my virtual system and not going through a router or a firewall. So to continue my enumeration, I perform two additional Nmap commands. The all port scan is used to discover hidden services by checking all 65 and 535 ports, while the service version detection identifies exact software versions that we can match against known vulnerabilities. So on the left of my terminal, I ran nmap-p to scan all ports on my target system. And on the right, I executed nmap-s with cap v for service version detection. So looking at the results, I found Apache with mode SSL running on ports 80 and 443. And this software is over 20 years old. I also discovered SMB services on port 139 and 445 running Samba. And then I found some non-standard ports like 111 and 32768. So this combination of outdated software and all these multiple services really makes this my system highly vulnerable. So for my first additional scan, I ran nmap-a for aggressive reconnaissance. This pretty much combine everything, including the OS detection, service versions, vulnerability scripts, and network tracing, all into one comprehensive command. The scan confirm my version, and it also reveal critical vulnerabilities. While SSH is relatively secure with encryption, the screenshot shows that the web services on port 80 and 443 uses weak SSL v2 ciphers. But the real concern from the screenshot is the SMB on port 139 and 445 because Samba is historically vulnerable and might be unnecessary. Also, there is a non-standard port which is 32768, which is running a status service, and all these will just add more holes to exploit. For my second additional scan, I ran nmap-s with capc, which is a default script that does an automated check for common vulnerabilities. So when I ran this scan, these are what I found out. HTTP has accessible directories on Apache 1.3.20, and the SSL certificate expired back in 2009. As you can see in the screenshot, that's over 15 years without updates. NetBIOS also show my Captric hostname with workgroup, my group, but SMB negotiation failed most likely due to an authentication issue. Furthermore, as you can see, SSH has encryption, but it's still very old, and this is a real problem because expired certificates and exposed web directories are easy targets. For my test scan, I ran Nmap with HTTP enumeration script to enumerate web directories. The scan found three exposed directories on Apache 1.3.20, icons with directory listings, manual with Apache documentation, and usage with server statistics. As you can see from the screenshot, this reveals system information that I could pretty much provide unauthorized access. Web services are less secure than SSH because they are publicly accessible and prone to misconfiguration. The bottom line is each directory is a potential entry point. The manual could reveal Apache vulnerabilities, and directory listings expose additional files. So I'm prioritizing web-based attacks as my primary path for exploiting this chaotic system. The methodology based on flaw hypothesis is a formalized method in which the penetration tester deduced possibilities of vulnerabilities by scrutinizing enumeration data and later exploit it. Having assembled service versions based on the Nmap scan, I compare the result with CVE databases to develop my hypothesis. According to having found Apache 1.3.20 with more SSL 2.8.4 and Samba are available on posts 139 and 445, my hypothesis is that OpenFork attack and Samba are very likely to be exploited remotely with 95 and 90% confidence respectively. The unpatched software, which has been in use since 20 years, default configurations, expired certificates, and weak SSL ciphers are very strong indicators of my arrival of successful root compromise using various attack vectors. So this vulnerability map shows the Chaotic 1 attack surface from my Nmap scan, including the IP address and the OS version, which has 7 open ports with major flaws. Red nodes mark critical issues, yellow indicate high risk ones. Key exploits include Apache Mo SSL buffer overflow with the CVE and Samba Trans2 open with the CVE as well, enabling remote root access. Other risks include outdated SSH, exposed directories, weak SSL or TLS ciphers, and non-standard ports. The map helps prioritize exploitation path by severity and success likelihood. So with the help of the Nmap scan, I was able to identify two critical CVSS 10 vulnerabilities in my Chaotic 1. The first is an Apache mode SSL buffer overflow with the CVE, as you can see in the screenshot, which allows remote access due to improper SSL handshake validation and missing boundary check. The second is a Samba Trans2 open buffer overflow with the CVE, as you can see again in the screenshot, which also leads to root access because of insecure default configurations and anonymous access. So both services were outdated and unpatched for over 20 years, making exploitation feasible once the vulnerable versions were confirmed. And this last slide is my references. That is where I got some of the information I've been talking about throughout this presentation. Thanks for your time and stay blessed.